Hi guys, hello everyone. Today I'm going to try to make a machine learning programming under 10 minutes. I'm going to be using MNIST dataset to detect hand digit numbers. So let's get started. I'm starting the timer now, and as soon as the timer starts, let's begin. First we have to import all the necessary things. So pandas SPD, this is very handy. ASP import lib.python.splt. Done. Next we have to get our data from TensorFlow. TensorFlow dot keras dot datasets import MNIST, and we have to get the data as xtrain comma ytrain comma xtest comma ytest. Alright, and then we have to load the data in dot load data. No error. Let's keep going. And then next train dot shape. Let's just check which shape. Yeah, we are all good. And then we have to go ahead and just to show you guys, I'll just plot this data for a sec. plt dot show and then let's plot the train one. Okay, so here you can see that one of the first or the second extrain element is 0. Let's go ahead and categorize the y values. If you take a look at y train of the same, it's going to give you 0, but we want to hot encode all this. So we have to import TensorFlow dot keras dot utils import to underscore categorical. And what we can do with this is we can import to categorical. Okay, now we have to convert the y cat train equal to categorical, and then y train and y cat test equal to categorical y test. Run this and y cat train of 1. Let's see. Okay, it's all good now. And then at last what we have to scale the x train and y train values. So x train, I'll just show you guys, of 1 dot max. If we run this we get 255. So we have to scale all x train by 255. X train equal to x train divided by 255. Same thing for x test. We have to scale it to values between 0 and 1. That's what a neural network or a machine learning algorithm can understand. And then yeah, we have to reshape this. So x train dot shape This is the shape of extrain value dot reshape. We need the exact same thing, but we need to increase the dimensions by 1 comma 1. Alt enter. And xtest dot reshape. Need to reshape this. With an addition of 1 dimension. Yeah, we are done. No, we have to equal to and let's just equal to do this. We shouldn't get any error. Yeah, we are good. And then we can start importing. We can start creating a model from tensorflow.keras.models import a sequential from tensorflow.keras.layers import total we need of course tens. We need tens, and then we need con 2d. Yeah, we need con 2d. Then we need max pooling 2d, max pool 2d. I think that's all we need. Yeah, we need to also get flat, and then we can create model equal to sequential model dot. We can start adding the layers. Add first layer is going to be our convolutional layer. And then filters equal to 32 comma kernel size equal to 4,4. We need to specify the input shape for the first layer. So input underscore shape should be input shape equal to 28,28 shape, and at last 28,1. And at last we have to mention activation equal to value. Yeah, the first layer is created. Model dot add max pooling, max pool 2d, and we have to give pool size 2,2. You can create bigger models, but we got very less time, so I'm going to create a very simple model. Flatten, pool size model dot. Now we have to add dense layer 124 128 comma deviation equal to, we are going to leave it as value. Model dot add, this is our final layer, dense. It has 10 different numbers from 0 to 9, so it is going to have 10 layers, and it is categorical. Categorical, it's softmax because it is multi-class classification. For multi-class classification, the final layer should always be softmax. Model.compile loss equal to categorical cross entropy. For multi-class classification, we always use categorical class entropy. Then optimizer, I'm going to use RM optimizer. Yeah, right here, optimizer, rather than using RMS prop. I'll use RM. And matrix equal to accuracy. Yeah, we are done with the model. Move it to summary, pretty simple model. Then we can fit the model, but before, flow dot keras dot callbacks import yield stopping. So this yield stopping will stop the training once it reached a optimal conditions. Like if it sees that it is getting overtrained, it will stop. Until that, it will ti enc equal to 2. So what this ALE stopping will do is it will stop the training once it feels like it has trained enough and it is fit x train, comma, we have to use cat train here, and we have to train this for epochs equal to 20. It will stop before that because we have the yearly stop condition. Validation data, this is the test data, so x test data and y cat test data, and at last callbacks is obviously yearly stopping. Okay. Yeah, there we go. Cool. What is the time now? It's 13 minutes. It's okay. This is taking time. I can stop the clock right here. Yeah guys, it's done. Let's go ahead and do a little bit of evaluation. Now loss is equal to pd dot data frame, okay, model dot history dot history, and then let's go ahead and take a look at it. Process dot head. There we go. Now I'm going to plot these losses. I'm going to plot accuracy with it. validation accuracy, .plot. This should give us a simple diagram of accuracy and validation accuracy. So you will not be able to see this properly since I'm in dog mode. Same code we can use for printing the losses. So we have the patience too, so it is waiting for more time for it to confirm that it's not training any better or it is getting overfitted. So if it sees that it is getting overfitted twice, then it is going to stop the training, even though we have like 20 epoch, it stopped training. That is equal to 0. Even I couldn't see what I was typing. Anyways, fine. We have a loss of this much and we have accuracy of 98%, so that's good. We did really good with this code from SQL learn dot matracs import classification report. There we go. And I mean, you guys, we have already completed it, but I just want to finish by also evaluating what we have done since we used pretty simple neural network. I don't know if it is going to be really good. Okay, we have predicted entire text test. Now let's just print classification report of y test, comma. Now we are just cross checking whatever we have predicted, that is our prediction visits the actual value. Predictions. Next we have to do the same thing for confusion matrix. We have to give the answer, the real answer, y test, comma, predictions. Should we give y cat test with its predictions? Yeah, then it will be fine. Let's just check y test. Okay, saying this won't really help us. We have to do a heat map, but let's go ahead and finish this with importing a number. Let's say I want number x test of 0. Okay, and plt, I'm going to show my number, show .28, 28. Yeah, we are good. So we are going to predict this number. So we can say that this is 7. Let us see how our model is going to predict. create classes my num dot reshape 1 comma 28 comma 28 comma 1. I think we are good. Yeah, it's predicting that it is 7, so we are all good. We have successfully made a CNN convolutional neural network model. Okay, it took me a little over 20 minutes, but it was this is my first coding challenge and I'm really happy that this came out good. I didn't have many mistakes. I did have some mistakes, but it's fine. So this is the code, guys. Anyone can create a machine learning model in under 10 minutes. I'm just a little bit slow in typing, that's why it took a little bit longer for me, but pretty simple. I'll also link this down in the description, this exact code. You guys can check this code if you want to, and see you guys with next challenge or next videos. Go check out my other videos or tutorials in which I teach how to do the same thing step by step, and I teach to implement tensor board. I teach how to make Raspberry Pi robots. So definitely check out my other videos. Click the subscribe button to see more, and give me a thumbs up if you like this video. See you guys later. Bye.